Good day and welcome to this webinar about industrial cybersecurity. Cybersecurity, industrial IoT, it's, let's say, connected, and it's not only a buzzword, it's the future of the connected world where you can think of millions or billions of devices being connected with each other. Think of security cameras, sensors, but not only on the consumer products, but especially also on industrial environments like vehicles, buildings, machineries with connecting lots of sensors and collecting a lot of data. So one of the trending topics within IoT is industrial IoT. Really, especially in manufacturing environment where industrial IoT can make a huge difference in terms of driving costs down, doing predictive maintenance, but also contributing to safety. So really a trending topic, to call it that way. And you can think of smart machines equipped with sensors, machines equipped with software, data analytics, and complex manufacturing and industrial processes. The industry IoT offers a huge potential and is, like I said, a true trending topic, but also safety and security are at stake. So therefore, in today's webinar, we will inform you about testing and certification possibilities for industrial cybersecurity. And it's my pleasure to introduce to you my colleague Antonio González, Technical Officer of the business line Cybersecurity and working for the Service Division Product Testing at DEKRA. Antonio, good morning.
Good morning, Vincent, and thank you very much for the introduction. As you say, there is no doubt that industrial cybersecurity is a trending topic right now. But also it is for many industrial sector actors, in which one of their main goals is to have a cyber-secure production plant. This is the content that we are going to cover today, remarking what are the possibilities that customers have to test and certify cybersecurity in industrial environments. First, we are going to see which are the challenges that industrial sector face. This will be a fundamental part to see how the services should be. Next, we are seeing some initiatives in countries and regions regarding industrial cybersecurity. Once we have a high-level picture of which is the current scenario of this industrial sector and which are the different initiatives, we are presenting the de facto standard for cybersecurity, for industrial cybersecurity, the IECEE 62443. At this point, we are going to review which are the best options to test and certify cybersecurity in industrial environments. Next, it will be shown which services can be offered by DEKRA related to the cybersecurity applied to industrial sector. Furthermore, using this standard for the industrial sector, the IECEE 62443, it will be shown which are the benefits that the customer can obtain for the industrial environment. Here, we will see an example to ground the matter, seeing how this standard can be applied to an industrial environment. Finally, we will show how DEKRA can meet your needs for industrial cybersecurity and be the best option for testing and certification. As we have said, if we want to offer services that make sense for our clients in the industrial sector, first of all, what we want to have to understand are the challenges that they face. There are different challenges that affect technical parts, the market or the budget. Budgetary, it is clear that since cybersecurity is not a regulatory requirement, it's still an unnecessary cost. And I say this in quotation marks because when we ask customers about which are their main concerns, cybersecurity and privacy are always there. Industrial systems usually have a long life cycle and working 24/7, so it is important that the corresponding controls and security measures will be the right ones. But since not always a physical access to the equipment is performed, for example, for updating or monitoring, security measures, as for example authentication, need to be in place and running as it should. Another of the significant challenges we face when we talk about industrial cybersecurity is employee safety. If an industrial system doesn't work as it should due to, for example, a cyber attack, the safety of employees can be compromised. And last but not least, it is key to consider the convergence between OT and IT. For example, the smart sensors will be able to collect the data from the source, such a factory floor, and transmit it to the organization systems out of the plant. This kind of interaction is the perfect place for new risk scenarios. All of these are elements that we need to take into account when we design certification and testing services. Once we know which are the important things that we need to understand when we want to test and certify industrial systems, it is good to know how industrial environments evolve during time. from the first industrial revolution in which manual labor were performed by people with the use of steam power engines, going through the introduction of electricity, as well as mass production during the second industrial revolution, till the first appearance of digital technology and automation software during the third industrial revolution, as a previous step to what we know as Industry 4.0. This industrial revolution makes an intense use of different new technologies, as interconnectivity through the Internet of Things, the access to real-time data, and the introduction of cyber-physical systems, that is, intelligent systems controlled by computer-based algorithms. But not everything is as good as it seems. As it was mentioned before, this new industrial revolution comes with a backpack full of new risk scenarios. Although Industry 4.0 has a lot of benefits, it also has new risk scenarios that never were considered in the past, but can affect in different ways to industrial environment. This could happen when malicious software is installed on industrial systems or an attacker gains control of them. If this happens, the industrial plant operations can be affected in several ways. For example, an industrial robot can turn dangerous to personnel, or even the whole plant can be switched off.
So, Antonio, these risk scenarios sound pretty abstract, but I'm pretty sure that you as an expert have some excellent examples how that works out for different industries. Can you give some examples?
Yeah, sure. You're right, Vincent. It could give the feeling that this scenario never happened, or if it happens, it's free of charge. Let me mention some examples that we allow to understand what could happen when a customer faces these scenarios. In 2005, a cyber attack caused 13 car manufacturing plants to go offline for almost an hour, leading to a 14 million loss. Or in 2017, in which a cyber attack to industrial safety systems leads to the shutdown of an industrial plant's operation. Or more recently, in 2021, a ransomware attack was suffered by Colonial Pipeline, and it cost at least the 5 million paid in ransom. These are only 3 examples of the new scenarios that the industrial sector is facing, and where DEKRA experts can help the industrial sector customers to be prepared to face these new scenarios.
So thank you for these examples, and they are pretty impressive, and also underlining the importance of cybersecurity for the industrial environment. So please tell us more about industrial cybersecurity, Antonio.
So next, it is important to know that the industrial cybersecurity is a challenge that not only affects the industrial sector, but also governments that have to ensure that the use of industrial systems are secure, safe, and that it complies with the corresponding regulations. In order to avoid or minimize these new cyber attack scenarios, we know that more and more countries launch different initiatives to address these challenges. Some of them develop their own initiatives and strategies, as Singapore, mainland China, or USA, and other regions, as the European Union, develop new initiatives as the NIS Directive for the industrial sector and the IECEE strategy. In any case, all of these initiatives, sooner or later, will be essential requirements for the industrial sector. In addition to these initiatives, it exists what is considered the de facto standard for industrial cybersecurity that will provide support for the secure operation of industrial control systems. More concretely, this standard is the IECEE 62443, an international series of standards divided into different sections, which describe both technical and process-related aspects of industrial cybersecurity. This standard divides the industry into different roles: the operator, the integrators, and the manufacturers. According to the IECEE 62443, these roles need to follow a risk-based approach to prevent and manage security risks in their activities. The IECEE 62443 is organized into the following 4 categories: general, policies and procedures, system, and components. The general documents provide an overview of the industrial security process and introduce essential concepts. This category contains basic information regarding concepts, models, and terminology, forming the foundation for the other categories. The documents on policies and procedures highlight the importance of these policies, because even the best security is useless if people are not trained and committed to support it. Aimed at end users and solution providers, this category covers the different aspects of creating and maintaining an effective cybersecurity management system. Because security can only be understood as an integrated system, the system documents provide essential guidance on designing and implementing security systems. This part describes the technical requirements for system design and provides guidance principles for the secure development and integration of systems. Focusing on the solution providers, the center of this category is the zone and conduit model, where these zones and conduits will be used as a way to segment and isolate the different subsystems contained in the architecture. Finally, and because it cannot build a solid building out of weak bricks, the component documents describe the requirements that must be met for secure industrial components. This last category contains all the technical guidelines for the development of products by manufacturers. System integrators and end users can also use them by taking the requirements as a basis for selecting and purchasing safe components for the system.
Antonio, you described the 62443 as a general standard, the effect of this standard for the industrial environment. Can you explain how that actually works for the different kind of industries?
Yes. So this standard can be either applied to industrial sector that don't have a specific standard for cybersecurity, or be the base for the definition of its own standard, as for example, the TR 50701 for railway, the ISO 8102-20 for lifts and elevators, or the more recent IECE 21434 for automotive, where all of these are considered extensions of the ISA IECE 62443.
Thank you. That's a good explanation, and also making clear that the 62443 actually indeed is a general one, but also applicable for different situations. Please.
So once we know which are the de facto standards for industrial cybersecurity, the ISA IECE 62443, it is needed to know which are the different options for our customers to be tested and certified against this standard. In order to test and certify according to ISA IECE 62443, nowadays our customers can find different options, which the most relevant are the ones related to the IECEE, ISA Secure, and the third-party seals. So next, one of the options for testing and certification scheme for the ISA IECE 62443 is the IECE scheme. This is a mutual acceptance scheme, that is, if one of the national certification bodies certifies a system, the certificate is accepted by the rest of certification bodies, which reduces the cost of having to certify in different countries. Under this scheme, the different chapters of ISA IECE 62443 can be certified. ISA Secure offers 3 different certifications in alignment with the ISA IECE 62443. The ISA Secure SDLA is a certification program that applies to the development lifecycle processes for control system products and certify compliance to ISA IECE 62443-4-1. The CSS certification focuses on the security of software application, embedded devices, host devices, and network devices. These are the component types used to build control systems that are defined by the standard ISA IECE 62443-4-2. Finally, the SLC requirements for certification include all control system requirements in ISA IECE 62443-3-3 and all process requirements in ISA IECE 62443-4-1. It is important to point it out that ISA Secure doesn't offer certification for ISA IECE 62443-2-4 as IECE does. Last but not least, there is another option for compliance certification, the one related to the third-party seals. Usually, the companies offer seals to their own certificates. These are a conformity seal about that the product has been tested and complies with the requirements of the standard.
Antonio, you present actually 3 options. You present IECE, ISA Secure, and the third-party seals. Why did you select those 3, and are there more?
Yes, because as it's part of the title, the ISA IECE 62443 comes from ISA and from IECEE. And in addition, the third-party seals are composed by experts that are the people that are part of the working groups that are developing the standard. So this is because these 3 options are the best ones.
So actually, you already make the pre-selection for us and for the audience. Thanks for that.
Thank you. So in addition, DEKRA offers high quality and trustworthy services. Our accreditation and recognition verify our well-equipped facilities, highly qualified personnel, and technical competence. DEKRA has the certification body testing laboratory, what is known as CBTL, status for the IECEE 62443 series of standard in Arnhem, the Netherlands, and Shanghai, mainly China, that allows DEKRA to support the customer obtaining the CBTest certificate and CBTest report for the IECEE 62443. In addition to this, DEKRA has the DEKRA Type Approved Seal to confirm compliance with IECEE 62443. More concretely, to the secure product development lifecycle requirements, to the technical security requirements for components, to the system security requirements, and for the security program requirements. This seal has different key points. The first one is that it comes from an independent and neutral entity with no other relationship with the customer. And the second one is that it is developed by experts that also contribute to the development of the IECEE 62443. With all of this, the next question is, which are the benefits that the customer can obtain from testing and certification against this industrial standard? One of the benefits is that tech companies offer a wide catalog of cost-effective solutions for testing and certification in terms of cost and time. After that, you have a testing team with proven experience in cybersecurity evaluation, years of experience, and certifications. It is important to clearly explain to our customers which is the state of the current regulation and which will be the requirements in the near horizon. And finally, rigor and excellence, both in the execution of the test and in the project management. But I think that the best way to understand how the certification against IECEE 62443 can help and benefit industrial environment customers is through an example. This example is based on a project developed by DEKRA, in which the IECEE 62443 is applied to an oil and gas industrial plant. First of all, the customer can use the IECEE 62443-2-1 as a guide to build its cybersecurity management system according to the requirements described in the standard. In addition to this initial step, the customer can perform a risk assessment based on the IECEE 62443-3-2 that will help the customer to obtain a target security level, SLT, using simple words, what is needed to obtain the desired level of security for its system. This target security level will be used by the customer to comply with the requirements established by IECEE 62443-3-3, where DEKRA can evaluate them to ensure that the established countermeasures are sufficient. In addition, by using the IECEE 62443-2-4, the customer will have a comprehensive set of requirements for security capabilities, which these requirements can be applied to integration or maintenance services. But we cannot forget that these systems can have components or subsystems that need to be certified. In this case, against IECEE 62443-4-2 and IECEE 62443-3-3 respectively. But before obtaining the certification against the IECEE 62443-4-2, it is important to point it out that the components need to be certified against IECEE 62443-4-1 for having a secure development lifecycle. To close this webinar, I would like to highlight that DEKRA can help the customer to achieve their goals in industrial cybersecurity, because DEKRA has a strong experience in testing and certification, and regarding to the cybersecurity, is accredited to offer a wide variety of cybersecurity certifications. In addition to this, DEKRA can offer to the customers a wide range of services, including vulnerability assessment and penetration testing, which can be used to carry on a security evaluation of the industrial environment of the customer. To improve the day-to-day performance of the security of the industrial environment of the customer, DEKRA can design custom and workshops for our clients. All of this is possible based not just on the wide experience in cybersecurity of DEKRA personnel, but also because DEKRA experts are part of the working groups that are developing the different chapters of the IECEE 62443, among other standards.
Thank you, Antonio, for this comprehensive overview of industrial cybersecurity. I have actually two questions for you. One is, what developments do you see in near future related to industrial IoT that will impact the testing and certification for cybersecurity?
For sure. This development will include, among other new smart industrial IoT systems, as embedded computers, machine-to-machine communicator modules, barcode scanners, sensors, or camera systems. Related to this, according to different research, the industrial IoT market is estimated to reach more than 120 billion by 2021. To secure these new systems, they need to be developed under the umbrella of industrial cybersecurity standards at the IECEE 62443.
Thank you, Antonio, for that. Final question. What's your advice for manufacturers who want to test and certify for industrial cybersecurity?
It is simple. As we saw before, cyber attacks to industrial plants were happening during the last years, and they are not going to stop because they are giving big benefit to attackers. We're talking about millions of dollars. The easy way to have a cybersecurity industrial system is by testing and certification. This will assure the customer that their industrial system and components are designed following a secure development lifecycle with a determined maturity level. And not only this, in addition, this system will have a security level that complies with the requirements according to their needs. And all of this covered by different international initiatives and industrial cybersecurity standards as the IECEE 62443.
Thanks. I think that's a good advice for the manufacturers. Thank you for watching. Stay tuned with us, and we will see more webinars coming up as well. Antonio, thanks very much, and I hope you enjoyed the webinar.
Yeah, thanks a lot for allowing me to show how DEKRA can help customers related to industrial cybersecurity testing and certification. Thank you.
Thank you.